All right. So this is the plan. And we it's a big breakout session, and so we can just play it by ear. But I thought probably the best thing would be for me to give an introduction to the structure of the container ontology, and then and maybe and the container server, and then so I'll do a pretty short presentation here, and then I thought we could move on to one of the Colab spreadsheets where I show how you can interact with the server, and then after that we could move on to actually working very much inside the ontology, either poking around inside it and working on expanding it, working with enhancing the container API, if that's interesting. One of the things I did was also collect up what I did to translate Stratios's catalog of microplates into the OWL format for use in the container ontology. And I think it would be possible to use that as the starting point for translating the OpenTrons labware catalog, if we're interested in doing that as kind of a project. Okay. So, and then, yeah, these are my assumptions, is that this is kind of the focus on what people will be interested in. And definitely, since I'm a computer scientist and not a lab biologist, everybody's going to know more than me about what should be in here. So I'm kind of facilitating getting it in there and making it usable. But if you see something that looks wrong to you, it probably is wrong. And we should just probably fix it. Okay. So just a quick background about how the ontology works. And the reason that this is here is that in a few minutes, I'm going to tell you things that are not normal about this, that you will need to know to understand how things work. But the normal stuff is that, we have classes, the classes have subclasses. OWL jargon, for whatever reason, uses the term individual instead of instances. And something that you need to know about how the container ontology works is that the individuals in the ontology aren't individual containers in the world. Instead, the individuals really correspond to catalog entries. And basically the reason that it is that way is that we need a way to tell when you look something up, when you've found enough information about a container. So when you've really gotten down to something you could order or, pull out of inventory. And if everything was classes all the way down, it would be very hard to know when your lookup is done. So here, you can sort of think of the individuals as, the individuals are really catalog entries, or if you want to think of them that way, they're like prototypes. So in PAML, you'll mostly want to point to one of these things rather than, you won't want an instance of these things. Okay. Instances have, just like in most schemes, instances have properties. A slightly oddball thing is that properties, there are two kinds of properties in OWL. One is a property that has an object as a value, and the other is a property that has a primitive data item like a string or a number. And that's just a constraint that comes from the way OWL is sort of fielded on the web, and also about just how the reasoner works. So you have to keep that in mind. And then again, just like in any class system, the class can have express constraints on what the property values can be. All right, so here's the big picture right now, and this was taken out of the Protege editor. This is the big picture of the microplate bit of the container ontology, which is really the only part that's been built out at all. Okay, so I guess the key things that you need to know is that, we've introduced classes for particular subtypes of plate that we need to talk about a lot, like the standard 96, 3084, and 1536 wells. And then we have some classes for the slash standards. For reasons which we could go into later, but for the moment, really the /4 standard is the only one that we could make much effective use of. And this one is the one that specifies how a microplate well is going to have the wells laid out and labeled. So you can say that you have a /96 well plate, and that means you know how to index it. So that's why that's there. And we have some, because we wanted an easy way to refer to some things in protocols. We have, opaque plates and clear plates, but those are just convenience classes. Okay. And then there are a bunch of properties used in the ontology. And Brian's talked already about how some of these things are inadequate and we need to expand these sets. I don't know, let's just skim down here through, and you can see the ones that are mostly used are available at. So you can have a lab, and you can say that you can assert that something is available at that lab, like available at Stratios or something. The instances will have catalog entries, maybe more than one. So you can say, who's the vendor, what's their catalog number. Let's see. We have some geometric properties which we can make effective use primarily for cases where I've been able to find a data sheet, but for some of these plates, I just haven't been able to populate this stuff. Oh, and we have colors, and one of the critical ones is the bottom shape for the wells. So those are some object valued properties. The data properties are similar. So we have catalog, if we have a catalog entry, well, that catalog entry will have a catalog number. Colors have color names. We have the row and well counts. Some of these are the numerical value is something for when we'd use measurements. And then we have lab names and vendor names that we can. So we have vendors that are sort of unique things, and you can refer to them by one or more vendor names to look them up, and that supports having a canonical representation for the vendors. Okay, so. Okay, so now if you want to make effective use of this, there are some unusual things about OWL that you need to know. And because it's not necessarily my favorite thing that OWL uses lots of terms that you're familiar with from other contexts like class and property and things like that, but it uses them often in ways that don't agree with what you're used to as far as meaning goes. And I tried to pull out here some of the key differences. So first of all, some classes have definitions, right? So what we're saying here is a slash for 96 well plate is defined as a microplate that has 12 columns, 8 rows, and 96 well count. Why does that matter? The reason it matters is that an OWL reasoner will use definitions to automatically classify instances and classes. So for example, if I bang out a description of a new instance and I say, well, it's a plate and it has, this well depth and 12 columns and 8 rows, and then the OWL reasoner will, I don't have to tell it that it's a slash 96 well plate. The reasoner will figure that out itself. And the advantage of that is that later on, when I say I need a slash 96 well plate, the reasoner is able to find all the things that satisfy that description. So what that really means is when you're defining a class, you have to think about what it's equivalent to and also what properties it has. So for example, here we just assert that a slash 96 well plate is a slash plate, right? It's a plate that complies with this standard. Okay, so there are things that we just assert about it, but then there are also things that the system will infer. Like here, it infers that this is a 96 well plate. I didn't have to assert that for it. And then another thing that's unusual is multiple inheritance is normal. Okay, it's a normal thing to do. So for example, here we have a clear 96 well plate, and that's defined as a plate that's clear and that is a / 96 well plate. Okay, so that's just a normal thing to do, because what OWL is sort of for is to classify things, and you want to classify on multiple dimensions. A single, if you wanted to do this kind of reasoning, just single inheritance doesn't really work for you. And notice, one last thing I should say is that the clear plate here, that's just a convenience. I could have written, that has value color clear instead of clear plate, because that's just the definition of clear plate. It's a plate that is clear. Okay, so we can do that equally well. All right. Okay, so so again, what's the point? What's the point? The point is that we can ask the OWL reasoner to tell you what well plates, 96 standard 96 well plates it knows about. Right. And again, this is using the Protege editor, but if you're working with PAML, presumably you'd be, querying the server for this information instead. And we can make compound queries, right? Again, the clear 96 well plate. And down here at the bottom, we can say, I need a clear 96 well plate that's available at Stratios, right? So I can express that kind of query in this sort of unusual syntax, where I can say, that I want a thing that has the available at property with the value Stratios. Okay, that's just the syntax that's used here. So that's really my introduction to the ontology. Why don't we do this? I'd like to see if this makes sense so far, and maybe what I'll do is close this presentation, and I'll share the screen with the Protege editor on it. And if anyone wants me to dig around inside that, we can do that next. So, yeah, are there questions about that structure? Does that just make perfect sense, or is there something that it seems unusual about that? Okay. This, so this is what the Protege editor looks like, and let's see. Let's see. It has multiple windows, so I think I did the sharing wrong. Let us try here. Okay. If you want to work with OWL, this is probably the best way to do it. The editor can be a little clunky, but it's a lot easier to work with than it is to work with the source code of the ontology. Sorry, Alexei?
Yeah, hi, Rob. You mentioned equivalence.
Yeah.
So you took the example of the 96 well plate. One of the things that usually happens in the labs is that there can be different orders and equivalent plates. So one day it's one brand, the next day it's another brand. When you populate your ontology, like, how would you do that? Like, do you start and you start with the first brand or whatever type of container, and then when you add the second one, you would say it's equivalent to that one? Or would you have some other sort of structure that tells you all the equivalents?
Oh, okay. So no, the classes are defined in terms of equivalence, not the individuals. So I think what I was saying effectively was that something like, so here's a query, right? So I have this slash 384 well played, right? And that has a definition. And let's see, I think I can say, I think it's the Welsh, and I can say well shape. I think it's V-shaped. Oh, shoot. Hang on for just a moment. I've done something wrong, which is, this is just the ontology, and I want to open the ontology populated with the Stratios catalog. Okay, so let's go back and say I want, I'll just have to look this up here. Visuals by class. Oh, I need to show everything. And now I can say, I can look at, for example, the well shape. Okay, so I can say, I have, oh, V bottom, thanks. Okay, so I can say, it should work. I've done wrong here. Oh, and yeah. So this should give me the this, I guess this is the only V bottom plate we have. So rather than saying one kind of plate is equivalent to another, you would define what you want. You give the description instead of, let's see if I can find let's see if this gives me, yeah, okay. So what you would say in your protocol, what you might say in your protocol is that I need a 384 well plate with a flat bottom. And then when you ask for those, when you get these instances, what you're sort of saying is, this is my requirement, and then all these plates that you got back should be equivalent with respect to your requirement. Okay, does that answer your question? So in other words, your protocol shouldn't say, use a Corning 384 flat white microplate. Instead, what would be better would be for you to say, my protocol needs a 384 weight well plate that's flat. Now, what I believe we could do, and is I can, one of the things I could do to help with this is, for example, I could look at, here I have I've looked up the Corning 384 well plate here, and I can find its description. And I can say, oh, okay, it's opaque. So if somebody gave me a protocol with that plate in it, I could potentially look at the description and say, well, the important thing is it's a 384 well plate and it's opaque. And the fact that it's available at Stratios is not important to my protocol. So does that answer your question better?
Yes, it does. But I was wondering, like, so most of the time, like when you look at the methods in publications, they would like specify the exact brand, model name, and all that.
Yeah.
But you're saying that in the PAML protocols, like we should sort of let the query of the containers be open and have just query for certain attributes and not put some specific brand name, whatever. Is that what you're advocating for?
Yeah, that's what I am advocating for. I mean, I think I guess the real answer is that it depends on how portable you want your protocol to be. And I mean, like, I think this is actually kind of a good example. If somebody gave you a protocol with that very specific microplate spec, that it has to be this Corning one, you could imagine, say, like I said, going back to the ontology and saying, well, I don't have those. What is that? Like what's its description? What is it? So that I can try to figure out what it is about that plate that makes it suitable for this protocol, so I can, come up with a better requirement than this. Because you could easily say, let's see, this thing does not. I'm going to try this, but I might easily get this wrong. So, one could imagine that you really have something like this. It has to have it, where the vendor is Corning and so forth. Yeah.
I got a question. So in your example before, you put something like what is it? A clear plate.
Right.
Do we have standards for the attributes that would be across all the different entries, so that we could query those attributes and make sure that we get a bunch of brands that are equivalent?
Actually, I'm not sure I fully understand that question.
Okay. Let's say that instead of me specifying the exact type, name, reference number, the entry, right? I'm going to define my panel protocol as I want a 96 flat bottom plate, clear, and with a certain height. Okay. Are these attributes standardized? Like, is there some sort of an ontology for attributes that would be common across the containers or something like that?
Yes.
Okay.
Yes. So yeah, those are the properties. So if we look here, all right, and here's a place where things are a little bit cumbersome, and we might want to think about how to make them better. So for example, if you've heard, we've had this discussion when we've presented PAML about how we use these measurement things. So for example, this plate has a height, but the height isn't just a simple measure. It's, let me see if there we go. Right, instead, it has this object in it that I have to look at and see that it's 14.22 millimeter height. And that's a little cumbersome and probably needs some thought, right? Because now when I talk about this plate, I might have to talk about a plate that has a height that is measured in millimeters and is less than 15. And expressing that is cumbersome. And that's also a good reason to introduce new classes, because it's easy to just make a class for microplates that are less than 15 millimeters high, stick it in the ontology, and then use it as shorthand going forward. Stick it in the ontology, or more likely, if you would make your own addition to the ontology and put your private abbreviations in there. Sorry, I didn't really pay the chat. I lost track of the chat. So I would say, no, there aren't any necessary plugins for Protege. I believe I added the debugger, but that's really the only one that I've added. Could I make it full screen? I can make it full screen. The only reason I didn't was that it likes to pop up sub windows. Let's see. Yeah. Oh, okay. No, sorry. That's good. I'll be more alert about the chat window going forward. Yeah, I didn't. One of the things. Let me see if I can get this. Let me see if I can do the there's a little difficulty working with the editor because it likes to pop up windows, but it's very rigid about them. So so for me to move information from one place to another isn't always easy. So if I wanted to do that, a query like that, yeah, the going back and forth to look up objects can be a little cumbersome. So let's imagine I want to find the, yeah. So let's say I want to find a plate that is that is, you know, this I have to, I have to say that it's got a height, and that height, Brian, you may know this, and that height is a thing that has a numerical value. I think this is like something like that. Yeah. That's might work. Let's see if that's right. But in order to really make this work, then I'd have to say, I forget if, is it a dimension or a measure? Has unit. Let's see. Yeah, as unit. Oh dear. Oh, sorry. Anyway, you can see it's cumbersome to work with dimensions. And probably something nicer than this will be needed going forward. Oh, Tim, yeah, I may have added extra reasoners as plugins. The reasoners should always give the same results for all queries, mostly. So the reason I say mostly is in mine, you'll see there's this one that's elk, and it only reasons about a subset of owl. And so it would not reach necessarily the same conclusion as one of the other reasoners. But fact, hermit, and pellet should all come up with the same answers. Oh, and by the way, you know, that shorthand here, let's just, one of the things that Protege will let you do, which is kind of handy, is, once I've figured out this query, and I agree, I didn't get it very well, but I've got this query here. I could take that and give a name to it and stick it in the ontology as a way of remembering the description of a, short microplate or a microplate that's compatible with this plate reader. And that's kind of a useful utility. Let's see, let me see if I get, okay, I think the rest of that discussion, I think is, yeah, it's okay. That has more to do with, I think, how you would use these entities. Okay, I tell you what, it is, we've been going, here's what I would propose. How about, let's take any more remaining questions and then take a 5-minute break, and I'll get the windows all arranged to use the Colab notebooks. And then we'll resume and we can look at the notebooks that I provided. Because there's one that sort of shows you how you might work with this. And then there's a second that shows how to load things, one way to load new information into the ontology or create a new ontology file. So is there anything else I could do, with Protege to sort of help you get acquainted with this? Maybe just, like a big part of the, I think those sort of the first windows you'd make use with are the classes, this entity master window lets you explore the classes, object properties, data properties. OWL also has annotation properties it's a place where you can put information that you don't need the reasoner to use, but that, is handy to keep around, comments. There's a bunch of examples here, but you can pretty freely add your own. I believe PAML heavily uses label as a way to get a readable view of its various things. Some of the biological ontologies use use entities like this, right? Where they're trying to be language agnostic, which makes sense, but it can also be, fudge. Here. They're trying to be language agnostic, but at the expense of having class and instance names that don't mean anything. It's C43377 is the, and you can see up here in the annotations that the label is what tells you what this means. To be honest, it would be nice if these labels were tagged with their names, with their languages, which is possible. Because in that case, it would be easier to use them in a multilingual framework. So, Let's see, those are the windows, and then the other one is, the instances. It's so, for us, we have a lot of plates, and if you wanted to browse around in there, you might look places like this. I'm wondering, oh, and it's showing only direct instances, which isn't really very helpful. Let's see, maybe it will show. There is probably a method to get it to show indirect instances as well, but I have momentarily forgotten what it is. Yeah. Oh, sorry, Tim. When you ask about that NCIT example, no, it's using OWL. What I was referring to was the human languages. So they give them these arbitrary identifiers, but then they use the label annotation to give you a name that you can actually understand. Yeah, no. Okay. Is there anything else I can answer with this now, or that you'd like to know about? I think I added the debugger, which is helpful if you're editing an ontology and you add and you're running the reasoner, the debugger will help you find if you've made the ontology inconsistent in some way, which could happen. Where if you make something a subclass of two classes that you don't fully understand, you might find that they assert conflicting property values, and the ontology will the debugger can help you find out how that's happened. Alexei?
Yes. Do you think you could show us in 1 or 2 minutes, like, let's say we take one container that comes from like a website, a database, OpenTrons or something like that, and how to enter that in Protege?
I think I can, but honestly, I'd rather defer that, because what I did in one of the Colab notebooks, I took the code I wrote to translate the Stratios catalog and put it in there. And so because that kind of translation can be cumbersome to do, I took the Stratios catalog spreadsheet, and I wrote a little Python code that walks it and makes instances that went into this Stratios catalog file. And I thought, as far as sort of, if we want to get our hands dirty while I'm here to support, I also pulled all the OpenTrons labware descriptions. Now, translating them would be a little different because they're stored in JSON instead of in a spreadsheet. But I think the bits and pieces of making up, what you would do with the JSON is very much the same as what you would do with a spreadsheet. It's just, you have an outer loop that's a little different. So I thought we could look at that next. I mean, I'll show you first how to talk to the server, but then I thought after that we could look at this this notebook, or rather, I have these two notebooks. One that is how I did the Stratios catalog, and the other is how here's how you load the Opentrons catalog, labware catalog, and we could work together to see how to adapt what I did for the spreadsheet into what you do for this JSON. Okay, so if it's okay, let's how about I restart at 5 minutes after the hour, and and that'll give me a chance to kill PowerPoint and get the Colab notebooks staged and on my screen and so forth. And everybody can stand up and stretch their legs for a minute. Okay. Just one. Hello, can everybody hear me again? Great. Sorry about that. Just make sure I have this. Okay, good. All right. Okay. So I hope this works for everyone. You should have a link to these. If not, let me know and I can try to post the link in the chat. Okay, will do. Hang on for a moment. Let's see. Here we go. There's a link. This is to the folder. It should be possible to you to copy these. It shouldn't. Ideally it will not be letting you edit them live, unless I did the sharing wrong. So this is just going to be a sort of a quick introduction to the container ontology server. So you can see how to poke it from Python code. And then we'll take a look at the Stratios catalog and how the import worked. Okay. All right, so there's just the container ontology still, I need to upload it to PyPy, but I should be able to do that pretty quickly and make that available. And then, okay. What I temporarily pushed set up the container server on an Amazon host so that we could test it here. It's if you have the ontology checked out and you have Docker, it's very easy to run the server for yourself locally, but I didn't want to have everybody have to fuss with that. If you you should be able to test this. If you click on that link, it should give you this rudimentary page that shows the container server's API and actually lets you experiment with it. So if you open one of these queries, you can look at you can try out some of the calls yourself. These get difficult pretty quickly, but for example, here you can say, this is the query that says, tell me all the knowledge bases you have. And it turns out there's only one, which is the container catalogs. And you can get some information about one of these. You can, again, try it out. We'll call it, it's ST2E container catalogs. And it will tell you some information. Basically the server has the Stratios catalog, a small catalog from BBN, the ontology of units of measure, and the container ontology in it. Okay. And let me I'll just show you one. This is, again, it's a little rudimentary right now. It's a little harder to work with than it should be, but we can make it easier without too much trouble. So this is the one, tell me about all the instances of some class. So I can say, so I can say, give me all the plates. Now, this is a bit of what I need to do is to tell it some abbreviations. So if you give me just a moment, and this is what I meant about being cumbersome. So I can say container is the abbreviation for the container ontology. And then I can say, give me the instances of plate in the container ontology. And if I haven't messed something up, that should work. And indeed, it gives me all the plates it knows about. And I can add give me the clear ones. And I should be able to do I hope this is, I might have the namespace wrong here, but let's see if that's right. Yes, it did not like Stratios. Anyway, so that is the server, and that's really what I just did. Was that helps, that documentation screen there shows you how, really lets you fill out a form to do exactly what you do if you were to call, poke the server, directly through HTTP, through the web. And in fact, if you look at it, okay, I'll get to you in one second. If you look at this, sorry, lost my train of thought while changing windows. I'll be, Alexi, sorry.
Yeah, quick question, since Brian's in the room. Does Taito talk to the server? Like, can we do queries through Taito to?
In principle, it should be, although I think this is the first time that we've had the container ontology on a public server. Now, another way that Taito can interact with the container ontology, and I have tested this, and it does work, is that if you have the container ontology file, like you've just downloaded the container ontology repo, and there's some turtle files in there. You can configure Tyto to interact with, to load those files locally into an RDF lib graph, and Tyto can interact with that. And that is actually fairly easy to set up. And that does work. Yeah.
I wonder if I should, we could set it up so that the container API does that for you. I can't really do this right now, but if you stick something if you stick an issue in, I can set it up to do that. And we could we could set it up so that you have the option to either use the local version or go to a server and just make it happen.
Another quick question is the idea that the bioprotocols group would maintain a server with a container ontology that we could all query and populate over the months and years? Is that something that is in the works?
Yeah, I think that's in the cards. I imagine we should talk about this. I imagine what one would want is to have the container. We could have a public server for the container ontology, and maybe you could have options to load different catalogs into it. But then the other thing you could do is run it locally. I was thinking, a commercial, if a commercial lab wanted to use this, they might not want to share their catalog. I mean, Stratios is sort of selling their catalog, so they're happy to have it there. But if you were a drug company, I could imagine you wouldn't want to do that. The way this is set up, you would imagine that if you have a local one, you would consult the global container ontology and then maybe layer additional information private to you on top of it in your server. And if you have the ontology checked out and you go to the OWL subdirectory, it should be as easy as typing make server to start it up on your own machine. And if it's not as easy as that, please file an issue and I'll fix it. Because you just load there's a Docker image that's pre-built for the server, and what that script does is just point it at the right collection of turtle files, and it just starts. Okay, and I need to modify that script a little bit so that you can add your own turtle files or other RDF files to that. But there's just a file there that lists other files. All you need to do is add to that. It's done.
Robert, what are the pros and cons of us hosting our own ontology server versus getting the container ontology onto one of the servers like Ontology? Are there advantages for us hosting our own service?
Well, they're sort of two different things, right? We should definitely put the ontology files themselves on something like Ontology and OBO maybe. But those servers don't provide all that the container server does, because the container server also has the OWL reasoner baked into it, so you don't have to figure out how to run your own. You just load the ontology files here, and it will, and you can do the queries. So that's the added thing. I mean, eventually we should, have a server, that loads the shared community ontology out of some canonical location like OBO or something like that. But so the only reason we don't have a public instance of the ontology server now is, it's just kind of a governance issue. If we have the server, then we have to be able to, respond if somebody cries for help, or it crashes or something, and we just need to have a framework to make that happen. And because it really took me half an hour to get this thing fielded on Amazon, and that was a half an hour for someone who hasn't used Amazon's AWS in 3 years. So it's really very simple.
Yeah, I totally understand why companies would want to have their private server and all that. But if we think about academic labs and iGEMers and something like iGEM, I think having a central place would be really helpful. I don't really picture telling any iGEM team, for example, say, hey, just run your own server for the ontology. All they want is access directly to something so that they can use that in a protocol directly. And I think it would be worth keeping that for the discussion later of how to put that in place.
Yeah, I think that's something we should just do in the PAML meetings, because it's just a matter of figuring out, how to maintain it, and that's not a problem. I mean, I don't mind doing a little bit of volunteer work, but I can't do too much, and we don't have a way of SIFT getting paid to do this kind of work. So, some institution that already knows how to do this would be good. Okay, so let's just quickly go through this, and I sort of think we should review this sheet a little, but it's mostly just there as a reference so that you could copy things and try it out. And it should be self-explanatory. So I'm hoping if we walk through this briefly, I can find out what isn't self-explanatory and fix it. Yeah, I think iGEM hosting its own server would be great, because there wouldn't be such an institutional heavy lift, right? Because you'd only have to make it work for the length of the iGEM event, and then figure out how to go on from there. Okay, so let's go back to how you can do this thing. So one thing you can do is really just, do the Python equivalent of using curl, right? This is just, this is that, what are the knowledge bases query, right? We send a request to the server for the KBS. They call them endpoints. places where, you know, you send a query for a particular thing. So the server, it has a bunch of different endpoints for different queries it can answer. So, right. So the first line here is the raw response, and then the second is, okay, that's the knowledge base name, and we'll use it from here. That I should have done. Right. So now we can say we know the one and only knowledge base that's hosted on the server, and then we can ask for some information about it. And then you can sort of see, so here's how you get all the instances here, and you could, you know, we could mess with the description of the things you want. All right. Right, I think this should work. I might get this wrong. Yeah, I bet I probably will get this. Let's see if this will work. I might not, it might not know enough namespaces to make that actually work, but we can try. Now, here I've just done something wrong. This may be a Python thing. Okay. I'm done something wrong, and we'll, oh. This might be what I've done wrong. But anyway, I will fix this and make a fixed version available. Yeah, I'll have to, I've done something wrong here, and I'm not sure what it is, especially since this worked a minute ago. I must have done something wrong there. Okay. The container API is minimal, but I think it should be built up. What I wanted to do here was, a lot of the above is just boilerplate and sort of a nuisance to work with. So, you know, so I wanted to make this kind of helper function, so that you can hit the server and without needing to know all the boilerplate here. So yeah, I think, and then there's the container API is layered on top of the Owlery API, which the Owlery is the name of the server system that the container server is built on. For the moment, I think this thing is not ready for prime time. The API spec isn't that they've written isn't thorough enough yet to make it convenient. If if this API spec is made more substantial, so the problem really is right now, if you look at these, if you look at these specifications, they don't really, they just tell you you get back equivalent classes, and they don't tell you much about what that means. And so the code that we generate from that is unnecessarily hard to work with. But I've been talking to the folks who've made Owlery, and they're committed to making this better and then supporting a better API that we can use later on. Right now, it's not clear to me that it's better to use that than just to, do the requests by hand. So, and actually, I will let me give you this. I should be able to give you an example here that will. I'll expand this example to show how to. Oh no, this one has it. Here we go. So when you need to pass parameters, you can do it with this framework, and this is probably just as easy as anything else. Yeah. So if there are any questions about that, we could take them now. And otherwise, I think looking at the Stratios catalog would probably be the most interesting thing to do. The Stratios catalog translator. And yeah. So is there anything more to know about this? I think probably what I should most do here to improve this would be to give a better description of what you can put in here besides container plate, right? Maybe, what the syntax is that you can put in those queries, because those are what you would put in your protocol as well. So I guess that would be probably the highest priority for me to do. But if there's other questions you have about this, we can entertain them now. Okay. Hearing none, let's go on to this. So what I've got here, and this is in that folder as well. What I've got here is what I did to translate the Stratios catalog, and this I've cleared the output, but I haven't. This should run for you as well. If you have a copy of this, I'd love to know if you run the first. You should get that catalog. I tried to make it publicly available. And you should be able to get the spreadsheet there to see how, what I used as the starting point for the translation. And let's see, what I should have done here is, yeah, I should be able to say, what are the columns here so that we can see what we have to work with, right? By the way, I think I have removed from this spreadsheet. Yeah. I took only the multi well plates. So this isn't the full catalog because this was just that piece of it. And then, yeah, and you can see I did a little exploration here to see what one of these entries was like. So I knew what to work with as far as translating. And I should mention, I didn't translate the whole thing. So there might be stuff, information here that would be interesting that is not yet in the catalog as it's been translated. Okay. So, all right. So, yeah, these are just, this is a bunch of throat clearing here. But I documented it because it's something that probably would just have to be copied over wholesale into any other translation. So what I did is I created an RDF-lib graph object that is going to hold the contents of the catalog. And then later on, we can dump that out into a file, and that's what will be the catalog file going forward. And so I should have explained that in this thing is that what I thought was the easiest way to do this was to build, basically to build this graph and then turn it into text instead of generating text by myself. Could have been done differently. But this is really the boilerplate that has to go on the top of an ontology file. Let me take just a moment here and we can go and see. This is the file that came out of that, and that's the front matter that just needs to be there. Okay. Now that's interesting. Okay. Yeah, more front matter. So what we do here is just say, okay, this is an ontology file, and these are the other ontologies it imports, and here's its name. Okay, so this, like I said, everything above here is boilerplate. If we were to do the OpenTrons catalog, we'd probably just copy that whole bit over. Okay. And then we're going to see, again, this is something that we could probably just copy right over to do a different one. So what we have to do for a lot of these properties is we have to make kind of intermediate objects. So when we want to say that, when we want to specify the vendor for one of these pieces of labware, right? We make a vendor object, right? And this kind of exposes a little bit more of the RDF than we might like, but basically, so let's just see what's happening here, right? We make a new IRI, so a web designator, like a link. Right, so we make a new one for the new vendor, and then we add a bunch of pieces of information to the graph, right? And the first one is, this is a vendor firm. And then it's readable, it's human readable name. And last we say, then we have this special property, which is add the vendor name property. Okay. And then you'll see what we've done there is stick that set of facts into the graph. So later on, when we're going to see that I'm going to need to look it up again, and that's what the find vendor is for. It's find me the entry in the graph for the vendor with this name. Okay. So, what have I done here? I have not closed. There. Okay. There. Okay. And then the making a container, a catalog entry is just the same thing, right? Right. This is a catalog entry. We point to the vendor object and add a catalog, which is, even though we call it a number, it's a string because they're not all numeric. Okay. And okay. And then after a couple of these, I realized that I was doing the same thing over and over again, and I started to do this, which is I'd make a Python class, right? And then the Python class would have a triples method. And so basically what you would do is you could always, all the code looks the same. You always need the triples method, and then everything about adding one of these intermediate objects gets easier, right? So we have a well depth, we have a height, we have a well volume, And again, this stuff you could carry it over to translating any new catalog, right? And then I have a bunch of utility functions. Yeah, add all the triples because that's something we do over and over again. Okay. All right, and then this is where the work gets done, right? And maybe it's worth looking at this pretty carefully. Let's see, these are, where did I, yeah. So we basically add these specifications, so we like we take each row, and from each row we pick the ID, the vendor, the catalog number, well count, column count. We make the objects, and that's how it goes. I think this loop may be not entirely correct. I'll have to, because I pulled it out of what I'd done before, but that's essentially what we're doing here. Yeah. Okay. So I thought that this might be an interesting thing for us to work on together. Here's the OpenTrons catalog file. So, and again, this is in that file on Google Drive, and you can get again, I posted this on as a GitHub gist. So now you can import the labware, and then I printed this. Prints just the all the properties in one record. And so you can see that this record acts very much like a row in the ontology, and in the Stratios catalog. It's, basically we would look at each one of these JSON dictionaries and translate it into a bunch of triples that need to go into the output file, and then we'd be done. So the real, kind of and then the tricky bit would be just figuring out what properties correspond to what pieces of the description, and do the translation. So that's 2 hours. So why don't we stop here and discuss this, and I'll answer any questions, and then we could think of some, what other, if we'd like to, spend a little bit of the remaining time and just try to do this problem, or try to do something else that you find interesting. And I should, yeah, because there's a number of things we could do if in a hands-on exercise, and that would probably, depending on your energy level, that would probably be a good thing, just in terms of being able to know what's, get a practical sense of what's there, and also but also bang on my head about anything that's wrong that should be fixed. So if there are any questions. Or anything you'd like me to return to explain.
Well, the one thing that's on my mind is we have somebody that's writing a protocol, say it's in just a Python file. What's probably the most natural workflow for them to configure their protocol with the container ontology?
I think I think at the moment, probably the best thing to do would be to work with Protege, and let me, this is a little bit repeating what our discussion with when Alexi asked the question this morning, but I think probably, excuse me, I'm just trying to get here we go, get this. So I think probably what one way to do this would be, let's say let's go back to the earlier question, right? So we had this,
So from that, it sounded like the trick was to write a query in Protege.
Right. And then, yep.
You'll see the results, and you might refine your query to narrow it down a little bit further, or open it up a little bit more. Mm-hmm. And eventually you'll have a query that you like, and you'll use that as the specification.
Right. So we could, I think this might be a good one to do if we, if we just take a couple of minutes. One of the things I should mention, this is a somewhat cumbersome thing about Protege, which I wish I had a better answer for, which is it's not possible, as far as I can tell, to use a modern tabbing interaction and copy information back and forth. So, right. So, you could imagine that we have our description here, and we say, okay, I don't, this is, it's not, this is, the interaction can be cumbersome. So what we want here somehow is to get Protege to let us copy this name, which it seems unwilling to do. Because let's try copying that. All right. Right. So, right, we start with this. Right. And then, okay, I don't have too many of these. So we can go back and say, maybe the height is important, right? So I'm going to say, okay, it's got to have a height, and that meets some constraints. And what we can do is we're going to look at the height we have here. There we go. Right. So we say, okay, let's say that what we think is we actually have some slop and we want it to be 12 millimeters or less, right? So let me see if we can. So, right, we have has. So I'm saying now I'm giving a description of the height there, right? And it's has unit, right? Okay. As unit. Oh dear. Oh, so it's not sure why it doesn't like that, but ah. Right, so we know it. Now we're going to say it's got a height measured in millimeters and as numerical value. Sorry, hang on a moment here. Right. So, and I'm afraid I'm a little, so then I can say, I believe this is right. I say some decimal number and I'll have to see if it's there. I'm not sure I have the syntax right here. It's something like this. And right, so I think it's, let's see if it's start with that. And then there's a way to make it less than that, but I have to remind myself what it is. But then you would take something like this, once you have it giving you results you think are sensible, presumably not giving you things that are wrong. And you take this string and paste it in as your container spec. Okay. And that, again, that would be if you're starting with a very concrete example and you're trying to generalize it to say what it is that you need. But then, of course, you know, it could be as simple as, you know, if you want this to be that's if you want to say, well, I'm supposed to be scalable. So the only thing I care about is that this be some microplate with a standard plate layout, right? So you can say, you know, I don't care if it's 96, 384 or 1536. That depends on how I want to scale this and what my lab equipment is capable of manipulating. The important thing is just that I know how to address the wells in the plate. It has to be standard. Or, you know, like I said, it might have to be clear. Or, you know, it might have to be a V-bottom plate. We had an example of someone saying it can't be a V-bottom, it can't be a flat plate because if it's a flat plate, then there are corners and I can't stir it as effectively as I want. Don't get a good mix. Okay, so those are examples. And, you know, I would be happy to provide support to anyone who, you know, tries doing this and finds that it doesn't work. Mm-hmm.
So I was wondering if there's like a good template for these queries that if it's something that doesn't really matter to you, that you would just leave it blank and it would be treated as like a don't care. But it seemed like they're always mostly going to be conjunctive statements, right?
Yeah, it would make sense. It would be a very sensible thing to do. And if you mention, again, it's hard for me to interact with it, but if you were to put an issue up saying, you know, like we should have a template for making container queries, that'd be great, because it would be something that wouldn't be hard to do, and that for people who don't necessarily want to work with Protege, you could imagine saying, fill out this template and then test it against the server. But yeah, if you would please write that down, that would be really helpful. You know, I will make that happen. And Tim, you're quite right. We should also make a bunch of classes that capture. So for example, this is actually an example here is clear plate is essentially the same as, if I remember, I might get this wrong, but it's basically and then actually I'm not sure if I think that's right. Yeah. See, so we introduced clear plate. because writing has color, some clear is a pain in the neck. So and and there's opaque plate as well. And actually, if you look, some of these vendors make them in colors, and maybe somebody wants to color code the pieces of the protocol, like, so it could be, I don't know if this is going to actually work. Yeah. So yeah, I think we could definitely add more child classes to make this helpful. If you were an organization like iGEM and you wanted, you had a lot of these to do, you could imagine also creating your own ontology file that has a bunch of definitions of classes that are just this kind of shorthand. Like maybe for sorting, you care that there's, about the colors, and you want to make blue plate, red plate, and green plate. You could do that. It's really it's as easy as and I think Protege actually will help me with this a little bit. So I can say, now, this isn't, why? Oh, it's a qualitative property, sorry. I could say, has color. Now is it may not let say okay, it's not going to let me do this. So what I would say is and now I have blue plate. And again, because it's definitional, the reasoner will automatically tell me what blue plates there are. So yeah, adding the shorthand is easy. Okay. Well, maybe we should call it at this point. And I'll be available to answer questions. Hit me up on Slack, send me an email, or post issues on the container ontology repo, and we'll try to make things happen.
So Robert, I do have a question. I was sort of trying
Sure.
to write it down to, maybe if I say it out loud, it won't be as clear, because I am kind of coming more from the biology side, trying
Sure.
to take sort of a pragmatic view of things. So it seems to me that this captures both kind of ontology considerations, as in like categorization of things, and it's also acting as kind of a database in that each instant, in its sort of ideal form, it would capture all catalog numbers for all plates that are out there. It feels to me like those concepts might be separatable, that maybe there's an easier way to sort of edit the database kind of aspect of it. Like, for example, you could have an Excel spreadsheet kind of that gets generated from the ontology, and then that could
Yeah.
sort of serve as the editable database then.
Well, the other thing is we could integrate into the existing framework. The Owlery server lets you hook in. We could hook in another something like a graph database. You could integrate it into the server. They do that, the people who made this. And you could have in it, for example, you could use that to do simpler sort of catalog lookup things. And the thing that we had been thinking about was if we could tie that into something like, if we could find a way that this could in a general way be tied into a local database, you know, the ideal thing would be able to say, have something like, you would add a file that says, yeah, these are all, you know, we have these 10 plates, kinds of plate. And what I'm going to do is add a file that, basically says, this plate in the container ontology, this, sort of canonical name that everybody can use. Our local catalog number for that is X. And then you could say, I'm just going to do a query and say, find me all the containers that meet the description in the way we've talked about so far, and then tell me what their local catalog numbers are, so that I can look up in whatever tool we have locally and say, do I actually have any of these on hand, or do I need to order them?
And I think that sort of starts to intersect with this idea of kind of inventory management, which is complex, of course. Like I saw one of the properties was, at a given lab, like at Stratios or something like that. So the more kind of concepts that get, the more modular it can be, it seems that it's easier to add things to it.
Yeah,
I mean, kind of what comes to mind.
Yeah, and already we do have, like, the Stratios catalog is just a list of these things translated from their spreadsheet, and it's a separate file, and you load it separately. You can load the container ontology without it, or you can load it and the container ontology and use them together. So so it it may actually sort of be more modular than the tools have displayed it as. I mean, I think that's probably that's an artifact that I showed you, either the server, which is supposed to take this big soup of facts and make sense of it, or Protege, which is just kind of rudimentary as an editor, and it doesn't really, it's incapable of showing you the fact that that we've integrated these things together. I mean, if you look at it, it will tell you, I could say, show me only the active ontology, right? And then you'll get very few things, right? But it's not really, I can't tell it to say, show me what came out of the Stratios catalog and what came out file and what came out of the container ontology file. It's just not, capable of doing that. And that's just because it was made at Stanford, and that's, that's what they wanted. And you don't, it's, yeah. So,
Yeah, I think it's interesting to me to sort of think about these problems kind of generally, because I'm probably coming at PAML and bioprotocols from less of kind of the lab automation side and sort of using microplates. I think it would be really nice to have complex workflows that are mostly people driven.
Yeah.
That could be sort of described in really discrete terms. But, for almost all cases of sort of using a lot of labware, I wouldn't say almost all, but a lot of cases, people just want to know it's a 50 milliliter beaker. It's made of glass. And
right.
And it's any other sort of information is really irrelevant to people. And it's probably never been written down in any biological protocol sort of from the beginning of the 1900s. Like people just say it's a beaker. So I can totally understand the lab automation side of things where it's like, yes, we do want to use this particular plate because this millimeter geometry kind of really matters for our process. And then there's this other question of, here's all this labware containers that a more manual biological process might use. Yeah, so I guess this all gets to the question, you can have a class that doesn't have any instances, I would suppose. Like you could have 50 milliliter beaker, and you'd be able to specify that in a PAML protocol.
And you would also be able to say, like, what are all the 50 milliliter beakers I know about?
But I'm saying, if you were to go to a typical sort of glassware cabinet in a biological laboratory, it's probably a whole mix of different beakers, and people just pull whatever's available. So it's really like a, as long as it's a 50 milliliter beaker, however that is defined, it is sort of suitable. So yeah, I guess, I'm trying to imagine how I can kind of contribute my knowledge to this greater initiative, and it, at least separating kind of the ontology concept more from the listing out catalog items concept seems to be a place where the ontology could be sort of quite more complete, yet not have to necessarily list any vendor, beakers from Corning versus, Amazon versus whichever. Yeah.
Yeah. I mean, in practice, we keep them separate, right? Like the Stratios catalog, and, and partly just also because as you saw, I just blasted through this spreadsheet and generated that file. And
I guess, it's sort of the way it's structured now. There's separate turtle files for separate catalogs. And I'm sort of wondering how to get away from this concept of necessarily needing a catalog item and sort of putting it in terms of like 1.5 milliliter microcentrifuge tube, 50 milliliter beaker.
Yep.
In some, for centrifuge tubes, in some protocols, they do actually call for, subvariants of it.
Yeah.
But for the most part, a lot of these things are just specified so generally because there isn't a ton of shared. Go ahead.
If I could make a comment. I'm coming from a different project, BioPAX. It's another one of these combine formalisms. It doesn't get talked about too much, but there we also it's defined in now. It was defined in Protege, just like everything that's being shown here, and with BioPAX, the idea is to collect molecular interaction information from different groups. So there's the Reactome group, the CAG group, and we wanted to have kind of a centralized repository of all of this molecular interaction information from all these different providers. And we have also gone through a phase that has been one where we created the ontology, as is shown with the container ontology. And the hope is that individuals like from Reactome and KEGG, etc., would put their data into our formalism so that we could aggregate it. So like is being described for Opentrons and Stratios, etc. And so with some of the larger groups like Reactome, that worked out. It required somebody from our team to be working with somebody directly on their team to figure out how to match up their entries to our ontology. And so that's kind of worked. But there's also a lot of people, and I think it's this conversation that was just being had. We want to be able to grab things from individual users or just from publications where maybe it's just a grad student or something, or somebody with a lot more limited time. And there it's been very hard to get somebody to actually go through all this effort of putting things into something like OWL. It just doesn't work. We have a nice, in a former life when Java was a more popular language, we have a Java API. It's totally usable. People could put things into it, but it's just it never panned out for smaller individuals, especially non-bioinformaticians. That just does not pan out. And I would give the suggestion, sort of like, and there's already hints of it with things like Stratios and the catalog or the JSON file, just figuring out exactly what is the most important data points that you require from somebody. And that kind of goes back to this conversation that was just being had about ignoring things like catalog numbers maybe, and just having it's this size of beaker. Like, what do you really need to move forward? Because you're going to want people to put in their various devices or containers, et cetera, into things for use with PAML. Once you start getting outside of a very small group of more bioinformatics oriented people, they're just not going to do it. Mm-hmm. Or you got to make it a lot easier than a lot of the things that we've been saying. It probably needs to be a spreadsheet, and you've got to very narrowly focus on these are the important data points, and getting somebody to pull out catalog numbers that just adds friction to the whole system.
Mm-hmm. Well, the catalog numbers are they're actually trivial, right? That's what you can get. So in that sense, like having the catalog material, the entries is kind of free. What I've been finding is that there's a lot of there's the catalogs have wildly varying amounts of information in them, from next to nothing to data, like a data sheet, which, I mean, as a computer person, I mean, if I look up an integrated circuit, there's like a data book, and it's surprising to me that you just basically, they say, yeah, it's green, it's got 96 wells, what do you want? And that's all you get from the website. And actually, Tim Dobbs was saying it's, what he would like to see all added is also, and this I think gets at your question before somewhat. He'd like to see some, more free-form information there that basically says, like, this plate is or is not compatible with this piece of lab equipment, because not only are the container specs kind of vague, but the equipment vendors aren't good about telling you, they'll tell you you can use this plate maybe from this vendor, but they won't tell you why. They don't actually tell you, like what the shape constraints really are, and so he was saying he's left a lot of the time to just sort of try things out and figure out if something will work. And so that might, having that kind of information, since often you don't know precisely the height, but you might know that this does or doesn't work with something else. And we've been talking about how one might represent that, make that available. Which I think kind of gets back to your point, because you could just say, like, oh, like here's this plate, and maybe I know it's this plate by this vendor, and oh yeah, it didn't work in my centrifuge or something like that. You just say, okay, I don't know why, but that's a useful piece of information and we want to have it there. And to get back to your point, we should try to find a way to make that easy to write down and easy to use, precisely because a lot of the people who benefit from that are the people who, are at the smaller places that, might be a real help.
Yeah. So on the point of the freeform things, also kind of connecting it back to this BioPack example, we definitely have a comment section for any freeform text, and I think I've had a decent history with the combined effort, and I think with every project that there needs to be some basic mechanism for extendability, and oftentimes we don't know what to do with that information, and just a blanket comment box or something is sufficient until there's enough put in there where you start seeing patterns of, oh, people are making certain types of comments that then you extend out the ontology. But definitely you need that kind of extendability. I will also say, just thinking about the catalog number, maybe I retract back a bit of my statement. So right now we're working on another attempt at an interface to get more just individual users to tell us about molecular interactions that they personally discover through their experiments. And we're calling the project Biofactoid, and we want it to be able to convert to this BioPax ontology. And there, it's meant to be a much more simplified version of data input. And a big thing that we have invested time into is something that we call grounding. And grounding is basically labeling with some kind of identifier. So it could be a catalog number in the case of the container ontology. But that's been a big thing. Once you have some kind of unique identifier for something, then you can write other scripts or just have other mechanisms to potentially fill out more pieces of information than maybe a human is willing to have the patience to fill out.
Mm-hmm. Yeah.
So a contain or some kind of unique catalog number, unique identifier, and then maybe code in the back, somehow in the back, scraping web pages or something to fill out other details. But yeah, for the experimentalist, a low bar of entry.
Yeah, absolutely. And I mean, of course, if you had something like that was searchable about, compatibility, then part of the low bar of entry might be just to be able to say, hey, I have this piece of equipment, like what works with it? What's known not to work with it? That, being able to provide that information might be a sort of a good way to get our hooks in people.
it's definitely a useful piece of information, but it kind of strikes me as more kind of a knowledge base type application, whereas
Yeah.
purely just having the protocol kind of work
Yeah.
is a lot more limited scope.
Yeah. No, I was just thinking if you could, have the sort of thing that, like Google would know to say, this equipment, this plate, yes or no, that might be helpful.
I think it's a
Just to make
tricky,
everybody easier.
it's definitely a tricky thing because it's, pretty much everything that's meant to work with plates should work with that slash format. And then problems arise when you have height, which is, I think in the ontology sort of demonstration, hard to sort of query at the sort of current point. And then there's going to be like low frequency sort of errors that happen, and that's not quite like, is it fully compatible or fully incompatible? It's just kind of like, is one better suited or less well suited? So yeah, it's definitely a tricky sort of thing to get at compatibility between instruments and containers versus just describing kind of the broad physical dimensions of things.
Yeah. Well, and one of the things that I discovered that was kind of shocking to me, again, coming from a thing where there's, like data books, is that the slash standards are broken.
Yes, they don't specify height. So then you run into this issue.
There's a height that they specify with tolerances. And then I looked, and most of the commercially available, commonly used ones don't comply. Like like when you take the slash and you put the tolerance around it, and then you take these, like these catalogs, they don't guarantee to fit. And it's not clear that, those standards seem dead, actually. There's nobody maintaining them, I think. So they don't really work.
Yeah, I think, my understanding is that in the late 1990s, early 2000s, there was this de facto kind of standard that had arisen. And this was an attempt to sort of make it more, actually on paper and have something that people could follow. So, how many people were already matching the de facto standard, but to kind of meet their customer needs, they didn't really change their mold process to meet the tolerances. It gets into sort of many questions of manufacturing, which are yeah. So I guess maybe the good news is that for the vast majority of labware, it's all kind of de facto standards. They're, it's not written down. It's just, use a 1.5 milliliter microcentrifuge tube. There's definitely differences between different vendors, and people might prefer one or the other, and materials come into play, surface treatments come into play. Yeah. So it was a nice shot, I think, for the slash standards, but.
Well, it's funny though, like so I actually sort of coded up the definitions from the ones for dimensions. And then I can't use them because I don't know what pieces are important and what pieces are somebody got the spec wrong and the tolerances are too tight, or it may be that the endpoint that they put the tolerances around is wrong and it should have been a little shorter, or, because when I typed it in basically, and then I started trying to look things up, I didn't find them. And the other thing is the data sheets often don't have the information you need to know if the, I mean, I found some data sheets that are fabulous, but others are just
Yeah, a
96
lot
well
of
played.
yeah, for sure. There's a couple companies that publish technical data sheets for all their plates. There's others that keep that kind of, and essentially the technical data sheets are like the instructions to the mold makers. So it
Yeah.
should be as close to reality,
Yeah.
barring sort of error that comes about in the mold making process.
Yeah.
Or the molding process. So, and then other companies consider it totally proprietary. So anyway, I'm sure you're kind of aware of all this, but it doesn't get better.
Yeah.
In other areas of kind of labware. Which is why I think when I've been sort of interfacing or trying to learn more about the container ontology, I've always kind of tried to approach it from kind of the pragmatic, like generalizing at angle. What about equipment? Particular instruments, if you want to call for particular catalog number or model number of an instrument versus the more general, just any plate reader will do. Because all this stuff is kind of implicit in the protocols that people write down in biological or chemical labs. It's just kind of, there's an expectation that, when the human is executing it, they'll sort of solve all these dependencies. It won't even say what container to use. It'll just say it'll just kind of give you a rough idea of, you're making something with this concentration. It may tell you how much to make, but it won't tell you exactly how to do it. So I kind of think from a pragmatic educational angle, really detailed, generalized biological protocols could be good for teaching, actually, because it's easier for students to they don't have to do this step of interpreting protocols.
Right. Yeah.
But it's a tricky thing.
Yeah, I think that's right. And here, well, anyway, it's interesting. We'll see how it goes. I think we're also just going to see, as if there comes to be more and more robotic lab automation, then some of this stuff will get tighter. It'll just have to. Yeah. I tell you what, I'm exhausted, so I guess I propose we call it a session, and I'm not just open to questions, but hit me up, because I'm fascinated to learn more and to make this better. So
thank you, Robert, for the demonstration.
Thanks, it's been fun.